All right, guys, so today we got into using the mirror equation, which is right here, to solve for magnification and the object distance and image distance and all that stuff. So this looks familiar. It's pretty much the thin lens equation. Works for mirrors too. Here's the magnification equation. This is important. A specific part of this that's important is that negative sign there. We'll talk about why that matters in a minute. We got to number 4. Had some trouble a little bit in period 6, 7, so I'd like to take another shot at it. So here we go. We know the converging mirror has a focal length of 20 centimeters. F equals 20 centimeters. Where should an object be placed? So we're looking for DO. And we have some formulas for that. We know it's either going to be, if we rearrange this, that M equals negative DI over DO. That means that DO equals negative DI over M. That's when we're going to do it. Or we can rearrange this guy up here and solve for it, but that's a lot to ask. So we're going to go down here. So we know that it's negative DI over M, which in this case is negative DI over 2. Another way to say this is that negative DI equals 2 DO. That's just doing some algebra and rearranging that. And what that says is that the image will be twice as tall as the object. The image is twice as tall as the object. So this is important. Moving on. So now we go to the original formula where it's 1 over DO plus 1 over DI equals 1 over F. So we can substitute. We know our DI now. It's negative 2DO. Say 1 over DO plus 1 over, I don't know why it's not working, negative 2DO equals 1 over 20 centimeters. So do your algebra at this point, and things get a little more straightforward. We rearrange up here. We end up with having 1 over DO minus 1 over 2DO equals 1 over 20 centimeters. End up with 1 over 2DO. Trust me, do the math. You'll figure it out. Maybe I'll help you out. I want this to be 2 on bottom, so you can compare the fractions. So if we multiply the bottom by 2 and the top by 2, it keeps this fraction the same value. Now we've got the common denominator. So we can say 2 over 2DO minus 1 over 2DO equals 1 over 20 centimeters. So when you do this math, you end up with 1 over, why it's not working here, over 2DO equals 1 over 20 centimeters. And it becomes obvious the DO equals 10 centimeters. All right, guys, I hope that helps. I hope that's a little bit more clear than what happened in class today. The secret here is in this guy right there, setting DO equal to DI or some function of it. All right, good luck. See you.